Hi everyone, this is Dr. Rebecca from Computer Science Engineering Data Science Department. Today in this class we will learn about multiplexing and spread spectrum technology from mobile computing subject. Now let us see in detail what multiplexing is. Multiplexing is a technique used in the area of electronics and signal processing. Multiplexing is a technique used in the area of electronic and signal processing. In mobile computing, telecommunication, and computer networks, multiplexing is a method that can be used to combine multiple analog or digital signals into one signal over a shared medium. Once again, I'm saying in mobile computing, that is telecommunication and computer networks, multiplexing is a method that can be used to combine multiple analog or digital signals into one signal over a shared medium. The main aim of using this method is to share a scarce resource. Sharing a scarce resource. Example, you can see in real time multiplexing in telecommunication field where several telephone calls may be carried using one wire. Multiplexing is also known as muxing. In detail, multiplexing is a technique that allows multiple simultaneous and analog or digital signal transmission across a single data link. Multiplexing is a technique that allows multiple simultaneous analog or digital signal transmission across a single data link. The main motive behind the development of multiplexing is to provide simple and easy communication, proper resource sharing, and its utilization. This is the best way to utilize and share a limited resource equally among multiple devices. The main motive behind the development of multiplexing is to provide simple and easy communication, proper resource sharing, and its utilization. This is the best way to utilize and share a limited resource equally among multiple devices. Now let us see one more good example for this multiplexing is in malls. We could see multiplex movies. Many movies run in a single place in different screens, wherein no two screens are interrupted. We can view uh, on a screen wholly and no two screens are interrupted. That is a very good real time example for multiplexing. Multiplexing can be classified into four types: FDM, TDM, CDM, SDM. Frequency division multiplexing, time division multiplexing, code division multiplexing, space division multiplexing. Once again, FDM, TDM, CDM, SDM. Full form for FDM: frequency division multiplexing, time division multiplexing, code division multiplexing, and space division multiplexing. Now let us see in detail each of these multiplexing types. First one, frequency division multiplexing. Frequency division multiplexing, or FDM, is inherently an analog technology. As the name specifies, in frequency division multiplexing, the frequency dimension spectrum is split into smaller frequency bands. One frequency spectrum is split into, for example, if this is a frequency band, this is split into smaller bands. It combines several smaller distinct frequency ranges signals into one medium and sends them over a single medium. In FDM, the signals are electrical signals. More points for this one. FDM's most common applications are traditional radio or television broadcasting, mobile or satellite station, or cable television. In cable TV, we can see that one cable is reached to the customer's locality or location, but the service provider can send multiple television channels or signals simultaneously over that cable to all the customers without any interference. The customer have to tune to the appropriate frequency, that is channel, to access the required signal. In FDM, several frequency bands can work simultaneously without any time constraint. See this one? Frequency bands are divided into different channels based on the time slots. Each channel again telecasts different programs individually. Here the constraint for division is frequency. For one frequency, one channel is designed. For example, in radio telecasting, we can see 91.1, 93.3 something, radio FM like that. For particular frequency band, a particular channel will run based on the allocation for that channel. Coming to the advantages of frequency division multiplexing, FDM, the concept of FDM applies to both analog and digital signals. Both analog and digital signals. These FDM can be applicable for both analog as well as digital signals. It facilitates you to send multiple signals simultaneously within a single connection. It facilitates us to send multiple signals simultaneously within a single connection. Coming to disadvantages, it is less flexible. In FDM, bandwidth wastage may be high. Usage, as I have already told you, in radio or in television, in both the cases, we can use this in cable TV and so on. Radio, based on the frequencies, the channels are divided. In television also, in a single wired medium, there we can telecast many channels. Next, second one is TDM, time division multiplexing. Time division multiplexing is digital or analog technology in few cases. In rare cases, it is analog technology, but usually it is digital. Coming to this one, instead of space or frequency, to separate here we use time. Instead of space or frequency, we use time for separate. To separate the different data streams, it uses for a specific amount of time in which the whole spectrum is used. The time frames of the same intervals are divided so that you can access the entire frequency spectrum at that time frame. Now let us see here, based on the time frame, the frequencies channels are divided. This is based on solely the time. Next, advantages of time division multiplexing are: it facilitates single user at a time. It is less complicated and more flexible architecture. Disadvantages is it is not easy to implement because only it facilitates only a single user at a particular instance of time. Whereas in the previous case, in frequency division, multiple users, because they share a frequency based bandwidth, there we can accommodate many users at a time. The usage, it is mainly used in telephonic services. Time division multiplexing, it is mainly used for telephonic services. For example, if we are on a call, for another one, either we need to add a call on a conference purpose, or else we can talk to that person after the call ends. After the first call ends only, we can communicate to that particular person. But whereas in other than time division, in other mediums, we can share media channels based on the frequencies. Here, for telephonic purposes, this is very good, suitable time division multiplexing. Next, code division multiplexing. Code division multiplexing, or CDM, allots a unique code to every channel so that each of these channels can use the same spectrum simultaneously at the same time. Here we use a unique code. With this unique code, every channel can use the same spectrum simultaneously at the same time. Here we can see this based on the codes. The channels are divided. Next, advantages of code division multiplexing. It is highly efficient. It faces fewer interferences. The data transmission is low. The disadvantages of CDM are data transmission rate is low. It is complex. Usage, it is mainly used in cell phone spectrum from 2G devices, 2G, 3G, 4G, and 5G also. Next, space division multiplexing. Space division multiplexing, or SDM, is called a combination of frequency division multiplexing and time division multiplexing. SDM equal to frequency division multiplexing plus time division multiplexing. It is combination of both frequency division multiplexing and time division multiplexing. It passes messages or data parallelly with the use of specific frequency at a specific time. It means a particular channel will be used against a specific frequency band for some amount of time. Here, this space division is done based on a frequency. For a particular frequency in that channel, based on the time, we can allocate the division in SDM. SDM, it passes messages or data parallel with the use of specific frequency at a specific time. It means a particular channel will be used against a specific frequency band for some amount of time. Coming to advantages, the data transmission rate is high. It uses time and frequency bands at its maximum potential. Disadvantages, an interference may occur. It faces high interference losses. Usage, it is used in GSM. GSM, full form of GSM is Global Service for Mobile Technology. Because these interference or losses occur, there came into existence spread spectrum technology. In spread spectrum technology, what we do is, it is a solution for this interference and losses. In space division multiplexing, interference occurs. There is a possibility of interference. As a solution for this interference, there came into existence spread spectrum technology. The problem of radio transmission, what here is, frequency dependent fading can wipe out narrowband signals for duration of the interference. The solution is spread and the narrow bandwidth into a broadcast band signal using a special code. Protection against narrowband interference. See this example. Here, the signal is being delivered. There occurred an interference. Because of this interference, there is a detection at the receiver end wherein it is added with interference, including signal. What happened here? The interference, it is shown with the pink color. You could see in the receiver end, what happened is, with signal, this spread interference is also received, so that this protection against narrowband, this is done using this spread spectrum technology. The side effects is coexistence of several signals without dynamic coordination, tap proof. The alternatives for this one is direct sequence and frequency hopping. Now let us see what direct sequence spread spectrum is. It is XOR of the signal with pseudo random number. This is nothing but some chipping sequence is used. For example, 128 bits result in higher bandwidth of the signal. Advantages for this one is reduces frequency, selective fading. In cellular networks, base stations can use the same frequency range. Several base stations can detect and recover the signals, soft handover. Disadvantages, precise power control. You see, we can see here the user data, it is XORed. XOR operation is used with help of chipping sequence, which generates a resulting signal. Here, with the user data, we are XORing the chipping sequence. Here, user data is 01. The chipping sequence is 011, 01101, and so on. Here, we are adding. You could see the chipping sequence here is this one, and the actual original user data is 0 and 1. Now, after performing XOR operation, the resulting signal is this one, which is transmitted. And the second one is frequency hopping spread spectrum. Frequency hopping spread spectrum, what happens here is discrete changes of carrier frequency. A sequence of frequency changes determined by a pseudo random number. There are two versions of frequency hopping spread spectrum: fast hopping, slow hopping. Fast hopping, several user bits per frequency. The advantages are frequency selective fading, interference limited to short period, simple implementation using only small portion of spectrum at any time. Coming to disadvantages, not as robust as a direct sequence spread spectrum, simpler to detect, several users bits per frequency. Here we can see in frequency hopping spread spectrum, as we have discussed, this has two versions, fast and slow hopping. That is clearly explained in this one. User data, user data, when it comes to slow hopping, it is 3 bits per hop. At a time, we are transmitting only 3 bits. When it comes to fast hopping, 3 hops per bit. That is, altogether, if we are using 3 bits per hop, it can transmit only 3 bits. Whereas when you are using fast hopping, 3 hops per bit, 3 hops, that is 9 bits can be transmitted at a particular instance of time. Here, usage of slow hopping or fast hopping is selected based on the frequency transmission requirement. Let us summarize today's class. Today we have seen multiplexing. Multiplexing is nothing but a combination of analog as well as digital signals, electronic, and this can transmit multiple analog or digital signals into a single medium. We have completed 4 types of multiplexing: frequency division multiplexing, time division multiplexing, code division multiplexing, space division multiplexing. In frequency division multiplexing, the division of the network is the channel is done based on the frequencies. For a particular frequencies, we are dividing it based on the channels. We have seen advantages, disadvantages. Coming to time division multiplexing, here the division is done based on the time. Generally, it uses digital signals. In some rare cases, analog technology is used. Here, the division is done based on the time frames. Each channel is allocated, each frequency is shared based on the time slot. Coming to code division multiplexing, we use a unique code for each channel. Here we can see for each channel we give some unique code. And coming to space division multiplexing is a combination of frequency division multiplexing and time division multiplexing. Based on the necessity requirement on a particular instance of time, the space is divided based on a particular frequency and time. In this, there is a chance for interference. For this interference, the only solution is spread spectrum technology. In spread spectrum technology, what we do is we give a solution for the interference spreading the spreading using the spread spectrum technology. And we have this in two types: direct sequence spread spectrum and frequency hopping spread spectrum. In direct sequence spread spectrum, with the user data we XOR with chipping sequence, this resulting signal is transmitted. In frequency, we look this frequency hopping spread spectrum in two technologies: fast and slow hopping. In fast hopping, there is a speed up in the process, because in slow hopping we can transmit only 3 bits per a hop, whereas in fast hopping 3 hops per a bit can be transmitted. Thank you.